Terraform is one of the most popular tools used by Devops teams to automate infrastructure tasks. It is used to provision and manage any cloud infrastructure or service. Terraform officially supports around 130 providers. Its community supported providers page lists another 160. Some of these providers just a few resources, but others such as AWS, OCI, or Azure have hundreds of them. There are cases where you simply have no other options. It's really hard to find a solution ranging over so many cloud providers. Additionally, if your case is a living system with a lot of infrastructure repetitions that undergoes minimal infrastructure changes every day, then Terraform is definitely an option worth looking for. Hello everyone, this is Dhruv from Edureka, and I welcome you all to this session where I will be talking about what is Terraform. So without any further ado, let's take a look at today's agenda. So we'll start this session by first understanding why one needs to consider Terraform and what actually it is. Then we will also understand how Terraform actually works and we will look at the life cycle of Terraform. Moving ahead, we will set up Terraform with Amazon Web Services and create a bucket in AWS using Terraform. And finally, we will end this session by looking at some of the industrial use cases of Terraform. So first, let's understand why one needs Terraform. So first of all, Terraform is infrastructure descriptive, which means it lets you define infrastructure in configuration or code and will enable you to rebuild and track changes through infrastructure with ease. Terraform provides a high-level description of infrastructure. Secondly, Terraform is open source, which means it has a lively community and also there's a massive community developing around this tool. Many people are already using it and it's easier to find people who know how to use it, plugins, extensions, professional support, etc. This also means Terraform is evolving at a much faster rate and they do releases new versions very often. Third factor to consider Terraform is its speedy operation. So Terraform's speed and operation are like really exceptional. One cool thing about Terraform is its plan command lets you see what changes you are about to apply before you apply them. Code reuse features and Terraform tends to make most changes faster than similar tools like CloudFormation. Also, Terraform is like the right tool for infrastructure management, as many other tools have severe impedance mismatch from trying to wrangle an API designed for configuring management to control an infrastructure environment. Instead, Terraform matches correctly with what you want to do. The API aligns with the way you think about infrastructure. Also, Terraform is the only sophisticated tool that is completely platform agnostic as well as supports other services. While there are a few alternatives, but they are focused on a single cloud provider. Lastly, Terraform has declarative codes, which means it enables you to implement all kinds of coding principles like having your code in source control, the ability to write automated tests, etc. Now that you have understood why one must choose Terraform, let's briefly understand what Terraform actually is. So Terraform is a configuration orchestration tool designed to provision the servers themselves. It refers to an arrangement and coordination of automated tasks resulting in a consolidated process or workflow. It is also an open source software tool created by HashiCorp. So HashiCorp created Terraform to manage, present, as well as popular service along with custom in-house solutions. Terraform lets you provision Google Cloud resources with declarative configuration files. Resources such as virtual machines, containers, storage, and networking. Terraform's infrastructure as a code that is IAC approach supports Devops best practices for change management, which lets you manage Terraform configuration files in source control to maintain an ideal provisioning state for testing and production environments. So this is about what is Terraform. Now let's understand how Terraform actually works. So this is the complete architecture of the working of Terraform. So we can divide this architecture into two parts. So first is Terraform core, which is this part, and second is the providers. So first let's understand Terraform core. So Terraform core uses two input source to do its job. So first input source is a Terraform configuration that you as a user configure. Here you define what needs to be created or provisioned. And the second input source is a state where Terraform keeps the up-to-date state of how the current setup of the infrastructure looks like. So what Terraform code does is it takes the input and it figures out the plan of what needs to be done. Then it compares the state, what is the current state, and what is the configuration that you desire in the end result. It figures out what needs to be done to get to that desired state in the configuration file. It also figures out like what needs to be created, what needs to be updated, and what needs to be deleted to create and provision the infrastructure. Now let's understand the providers, which is the second component of the architecture for specific technologies. So this could be like cloud providers like AWS, Azure, or Google Cloud Platform, or other infrastructure as a service platform. It is also a provider for more high level components like Kubernetes or other platform as a service tools, even some software as a service tool as well. It gives you the possibility to create infrastructure on different levels. For example, you can create an AWS infrastructure, then deploy Kubernetes on top of it, and then create service or components inside that Kubernetes cluster. Terraform has like over 100 providers for different technologies, and each provider then gives Terraform user access to its resources. So through AWS provider, for example, you have access to hundreds of AWS resources like EC2 instance, the AWS users, etc. With Kubernetes provider, you access to commodities, resources like services and deployments and namespaces, etc. So this is how like Terraform works, and this way it tries to help you provision and cover the complete application setup for from infrastructure all the way to the application. Now let's understand the Terraform cycle, which is the major commands of Terraform that we give in command line interface. So first one is Terraform initialization. So this command is used to initialize working directory containing Terraform configuration files. Then the next one is Terraform validate. So validate like runs checks that verify whether a configuration is systematically valid and internally consistent, regardless of any provided variables or existing state. It is thus primarily useful for general verification of reusable modules, including correctness of attribute names and value types. So the third one, the sequence is a Terraform plan. So this command like creates an execution plan. So by default, creating a plan consists of like reading the current state of any already existing remote objects to make sure that the Terraform state is up to date, comparing the current configuration to the prior state, and also for noting any differences. And it also consists of like proposing a set of change actions that should or if applied make the remote objects match the configuration. Now the fourth one in the lifecycle is Terraform apply. So this command executes the actions proposed in a Terraform plan. So the most straightforward way to use Terraform apply is to run it without any arguments at all, in which case it will automatically like create a new execution plan and then prompt you to approve that plan before taking the indicated actions. And the last one is Terraform destroy. So this command is like convenient way to destroy all remote objects managed by a particular Terraform configuration. So this was an overview of all the major commands. Now let's briefly understand their usage as well and how we use it. So the usage of Terraform initialization is such that this command performs several different initialization steps in order to like prepare the current working directory for use with Terraform. Then command is always like safe to run multiple times to bring the working directory up to date with changes in the configuration. Though subsequent runs may give errors, this command will never delete your existing configuration or state. So now let's understand how this Terraform initialization works. Let's go to command prompt. So there is this folder of Terraform I've created. I will let you know how this process works. Right now, I'm just explaining you what initialization does. And I have already like in further steps, I'm going to show you about how like create a like user in AWS and how to create the storage bucket as well in the AWS. But like I have already created a user. So on the basis of that, I will initialize Terraform. So let's start this. So my location of the folder is stop cd demo Terraform. Now if I initialize, so the code which is working in the background that I have in VS Code is of creating a bucket. So for that purpose, I have initialized Terraform, and right now you can see the initialization is being done. Now let's understand the second step, that is Terraform validate. So like Terraform validate, as I told you, like command validates the configuration files in a directory, referring only to the configuration and not accessing any remote services such as the remote state or like provider API, etc. And its usage is such that this command accepts the following options, as you can see here. So when you use the JSON options, so Terraform will produce validation results in JSON format to allow using the validation results for tool integration, such as highlighting errors in a text editor. And if you use no color, then the output which we get will not contain any color, like you can see here. If you specify no color, then like right now, let me give Terraform validate. This is the we are giving command prompt. So Terraform validate. So it will validate the directory, like all the configuration files in the directory. This is what I mean. So yeah, you can see the configuration is valid, and you can see the output comes in green color, right? So that was about the color and no color thing. Now let's understand the third step. So the usage of Terraform plan. So plan command, as I told you, like alone will not actually carry out the proposed changes, and so you can like use this command to check whether the proposed changes match what you expected before you apply the changes, or share your changes with the team for broader review. If Terraform like detects no changes are needed to resource instance or to root module output values, Terraform plan will report that no actions needed to be taken. So the plan command like looks in the current working directory for the root module configuration, because the plan command is one of the main commands of Terraform. It has a variety of different options described in the following sections. However, most of the time should not need to set any of these options, because a Terraform configuration should typically be designed to work with no special additional options for routine work. So it has like different options and modes. So first is the planning mode. So there are some special alternative planning modes that you can use for some special situations where your goal is not just to change the remote system to match your configuration. Then there are planning options alongside the spatial planning modes, and there are also some options you can set in order to customize the planning process for unusual needs. Then there's resource targeting, which is one particular spatial planning option that has some important caveats associated with it. So then there are other options which change the behavior of the planning command itself rather than customizing the content of the generated plan. Now the next one is Terraform apply. Also, I will let you know about these commands in the command line in the further steps when I will showing you the elaborated demo. That time I will explain you how it works. So let's like all the Terraform plan, Terraform apply, and Terraform destroy. So right now let's understand Terraform deploy, the usage of it. So as I've told you, like Terraform commands executes the actions proposed in a Terraform plan. So like the behavior of a Terraform apply significantly differs depending on whether you pass it in a file name of a previously saved file or not. So there are like two modes in it. So the first mode is automatic plan mode. In the default case with no saved plan file, Terraform apply creates its own plan of action in the same way the Terraform plan would. Terraform will propose plan to you and prompt you to approve it before taking the described actions, unless you waive that prompt by using the auto approve option. When performing its own plan, Terraform apply supports all of the same planning modes and planning options that Terraform plan would accept. So you can like customize how Terraform will create the plan. Then there is saved plan mode. If you pass the file name of a previously saved plan file, then Terraform apply performs exactly the steps specified by that plan file. It does not prompt for approval. If you want to inspect a plan file before applying it, so you can use Terraform show. Means there's a command called Terraform show for that. So when using a safe plan, none of the planning modes or planning options linked above are like supported. These options are only affect Terraform's decisions about which actions to take, and plan files contains the final results of those decisions. Now the last one, which is Terraform destroy. So as I told you, like Terraform destroy command is like very convenient way to destroy all remote objects managed by a particular Terraform configuration. While you will typically not want to destroy long-lived objects in a production environment, Terraform is sometimes used to manage like ephemeral infrastructure for development purposes, in which case you can use Terraform destroy to conveniently clean up all of those temporary objects once you are finished with your work. So its usage is such that the command is just convenience alias for this Terraform apply command. So you can use in such a way like you can give command as Terraform apply hyphen destroy. For that reason, this command accepts most of the options that Terraform apply accepts, although it does not accept a plan file argument and forces the selection of the destroy planning mode. You can also create a speculative destroy plan to see what the effect of destroying would be by running the following command. As you can see here, Terraform plan destroy. So this will run Terraform plan in destroy mode, showing you the proposed destroy changes like without executing them. Note one thing, like the destroy option to Terraform apply exists only in Terraform like version 0.15.2 and later on. For earlier versions, you must use like Terraform destroy to get the effect of Terraform apply destroy. So now let's set up Terraform with AWS. So before that, you also need to understand that you have to download Terraform. So let me tell you how to download. Just Google Terraform download and come here. So here you will find for all the OS, you can find different bits, whatever your system is, like with 32-bit or 64-bit or ARM. For that purpose, you can find Terraform in it. Like I have Windows, so I will download it. Click here and I will download. I have already downloaded it, so that's how it's been downloaded. simple. And then we need to set up Terraform with AWS. For that, we are going to create a user. So let's go to IAM. This is the AWS management console, as you can see. So I will just go to IAM. So just go to users. As you can see here, there's already a user created. I will just destroy this. So delete. I can create my own user. You can like create multiple users as well. I just deleted it for like my comfortable. So username I will give Terraform demo. Just give access key as well. We need the access key for running it through Terraform. So next permission. Attach existing policies as well. So here I'm gonna give administrator access, the complete access. Next tags not required. So you can review everything. So now create user. So this is, you can see here, access key and secret access key is being created here. Remember that your access key and secret access key shouldn't be exposed to anyone else, which is because it can become a security concern. So keep it secret. Like by the time you will be seeing this video, the user will be deleted. So these access key and secret access key will be of no use to anyone who is viewing this video. So our next step is we are going to create a S3 bucket in AWS. So for that, you need to have any IDE. Like I am using VS Code here, Visual Studio Code. So here I have like the main.tf file. You will find this code in the like the description box below. So here I have, you can see like I have given the provider, which is because I'm going to create a bucket in AWS, and then there is region, and the same access key and secret access key are present here. Create your own region. So then resources, I am creating AWS S3 bucket. So I'll just give it as AWS S3 bucket 1. 2 I will give, because as you can see here, just a sec. Yeah, I'll just show you S3 bucket. So right now you can see like I have 2 buckets right now. So I'll be creating a third one, which is AWS S3 bucket 2. This is the resource. So not here. Yeah, here. So this will be 2 AWS S3 bucket. So I will just save it like this, and I will create a private and name and environment you can give. Then let's go to, I have told you to download Terraform. So keep that file of Terraform and this code in the same place in a folder. Like I have it in a certain place like folder, and in this in demo the Terraform, and the Terraform I have both the files. The exe file, which is the application which you downloaded, the Terraform application, and other than that the main file, the main.tf file, this one. Now let's open the command line. Okay, close this one because this is the demo I showed you. I will just close this one. Let's start from the initial phase. So let me give the path. So after this, we have to give those lifecycle commands as I've explained you. So Terraform initialize. So it's been initialized. Now I will validate. So you can see the configuration is valid. Now we will just plan. So give Terraform plan. So as you might remember, like Terraform plan command creates an execution plan. So it's just getting created. So the plan which is being created now, to execute that plan, like the proposed plan, we need to give the command like Terraform apply. So you just have to give the yes value here because it accept only yes. So also you can like see here, like it is showing AWS S3 bucket will be created when you give the apply now. Terraform apply, it shows that it's getting created. So you can see here like the bucket is created. Now let's go to our AWS console. I've showed you like 2 buckets were already existing, so which I created before. So now let's see the third one is created. This is the storage bucket in which we can like save our files and everything. Like you can open this bucket and you can like upload your file and everything, whatever you want to, and it gets uploaded here. From here you can upload. Right now I can cancel, like right now, go to this option. So 3 buckets are there. Now the last lifecycle command, that is to destroy this bucket. So for that I will give Terraform destroy. So yeah, I want to destroy it. That's just a confirmation. So now you can see process is complete, and you will see like this one will get disappear from here. Our bucket, that is my TF drop bucket 2. Refresh it. So now you can see our bucket is deleted. Now our hands-on is completed. So now let's understand the industrial use cases of Terraform. So first is a Rapider, which is a consultancy company. So what happened with Rapider is that the DevOps engineers at Rapider Cloud Solutions reviewed and analyzed the client's requirement, where the need was to orchestrate the infrastructure within few minutes, and that also should be cloud agnostic. So engineers at Rapider used Terraform to codify the provisioning of infrastructure onto the public cloud and enable this provisioning to these clouds through automation. So by automatic manual configuration, they also eliminated the possibility of human error. So another use case is of semantic bits, which is a software firm. So semantic bits used the Terraform modules and variables to effectively build a complex AWS infrastructure required for a complex application. For the extensive use of modules with appropriate variables, made the code very reusable and manageable in size. So what they did is to enable the use of resource definitions and deployment code for each type of resource is created as a Terraform module, and Terraform configuration files for each module goes into its own subdirectory, and the main Terraform configuration at the root level composes the modules to build the complete infrastructure. Each module may be called the multiple times from the whichever the main provider file with appropriate values for the input variables and to create individual instances of the resources. So module configuration for each module is split into two Terraform files, and so one with module.tf defines the actual resource and created by the component, and other one named module.variables.tf defines all the input and the output variables of the resource created by that module. So any resource or properties that need to be configured for deployment is defined as input variables, and any attribute of the resource that may be required by the caller are defined as the output variable. So in this way, semantic bits created a complex AWS infrastructure using Terraform, which has actually eased out a lot for the company. So third is of Mitoc Group, which provides incremental value by automating the management at scale of large amount of cloud services and cloud resources that run in customers' private networks built on top of public clouds. So Mitoc Group empowered customers to set up infrastructure as a code and automated workflows using a combination of the two open source projects, that is using Terraform and TerraHub. Next and the last use case is of OpenCredo company. So using Terraform, trusted and supported provider like Terraform verified status was achieved. So there was also improved developer experience. So ability to use latest Terraform and upload features as well as the clear documentation was done. So how it actually benefited is using Terraform, there was an increased ease of adoption. So instead of developing bespoke tool which requires specialist skills to operate, creating a custom Terraform provider aligns your provisioning process with other infrastructures resources and makes it easier for engineers to incorporate into automation pipelines, thus removing barriers to adoption for organizations who are using Terraform. Then Terraform also helped OpenCredo in reducing market friction and for expanding market reach with the continued adoption of many organizations. Terraform has become a market leading tool for managing infrastructure. Having a custom provider will reduce market friction and expand your market reach to these organizations. So this was all about the industrial use cases of Terraform. And with this, we come to the end of today's session of What is Terraform. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section below. Until next time, thank you.